Let us first write out the ionic equation for the respective ion discharges. Each mole of silver ion requires 1 mole of electrons to be discharged into 1 mole of silver atoms. So half a mole of electrons can only discharge half a mole of silver ions to get half a mole of silver atoms. Half a mole of silver atoms multiplied by the atomic mass of silver, 108, you end up with 54 grams of silver. So at this point in time, A, B, D are possible answers. Next, the copper 2 plus ion requires 2 moles of electron to be discharged. So half a mole of electrons can only discharge a quarter mole of copper 2 plus ions to get a quarter mole of copper atoms multiplied by the atomic mass of copper, 64 grams, and we end up with 16 grams of copper. At this moment, B or D are possible answers. Finally, when we look at aluminium, now remember, when it comes to the preferential discharge of positive ions, the ions that are further down below the reactivity series will be discharged in preference. Now in the aluminum nitrate solution, what are the cations present? There are 2 cations present, the aluminum 3 plus ion and the H plus ion. Now since the H plus ion is below aluminum 3 plus in the reactivity series, H plus will be discharged. So you will get hydrogen gases bubbling at the cathode. No aluminum shall be discharged. Hence 0 grams of aluminum are discharged. Hence the answer is B. Let us now examine the electrolysis of aqueous copper sulfate using platinum anode and copper cathode. So first we draw the battery. The positive electrode is connected to the platinum anode and the negative terminal of the battery is connected to the copper cathode. Now the anode supplies electrons to the battery, and the battery will pump the electrons to the cathode. For the anode to get electrons, it has to get electrons from the negative ions, the anions. There are 2 anions in solution, the sulfate anion and the hydroxide anion. Sulfate ions never get discharged. Instead, the hydroxide ions will get discharged. So oxygen gas will bubble out at the anode. At the cathode side, the electrons can discharge positive ions from solution. There are 2 positive ions, the copper 2 plus ion and the hydrogen ion. The hydrogen ion is higher in the reactivity series. It will not be discharged. Instead, the copper 2 plus ion, which is lower down in the reactivity series, will be discharged. It will be discharged by receiving 2 electrons to return back to the copper atom form. So copper atoms will start to accumulate around the cathode and you end up with a more massive cathode. So the mass of the cathode will increase. The answer is A. Answer is not B because the cathode cannot be 0 mass from the start. Let us look at question number 3. We have a zinc electrode connected to a copper electrode through an external wire through what looks like a light bulb. So this is a simple voltaic cell. The more reactive zinc will give electrons to the less reactive copper. Electrons arriving at the copper electrode will be able to discharge positive ions. There are two positive ions at the copper electrode, the hydrogen ions and the sodium ions. Between the two, the hydrogen ion, which is lower down the reactivity series, will get discharged and you will get hydrogen gas bubbling around the copper electrode. On the other side, when the zinc gives up the electrons, they will become zinc ions. That is all that happens. Let's look at the options. A. The copper electrode increases in weight. That is not true. That is true only if the solution contains copper ions and then copper ions can be discharged to become copper metal. Option B. The solution gradually turns blue. That is also not correct because copper atoms are not going into solution. It's the zinc atoms that are going into solution. C. The solution becomes alkaline. That is correct. Originally, in the sodium chloride solution, we have a balance of H plus and OH minus ions. But as the H plus ions gets discharged, there will be more hydroxide ions remaining in solution, hence the solution becomes more alkaline. D. The chlorine gets discharged. Chlorine gets discharged only if this were an electrolytic cell and also only if it were a concentrated sodium chloride solution. Question number 4. The electrolysis of sulfuric acid is actually the electrolysis of water itself. Why? Because H2SO4 contains H plus ions and sulfate ions. Water itself also provides H plus ions and hydroxide ions. So the cation is definitely H plus. And between sulfate and hydroxide anions, sulfate ions never get discharged. It is the hydroxide ion that gets discharged. So in the end, we are just discharging water. When it comes to discharging water, the ratio will always be 2 hydrogen to 1 oxygen. So we will have 2 moles of hydrogen for every 1 mole of oxygen gas. We can convert the mole ratio to mass ratio. So 4 hydrogen atoms weigh 4 grams and 2 oxygen atoms weigh 32 grams. So the mass ratio has to be 1 is to 4. Sorry, no, wait, 1 is to 16. No, 1 is to 8. So let's look for a mass ratio of 1 is to 8. This is 1 is to 4. It's not correct. 1 is to 16 is not correct. This is 1 is to 8. So this is correct. What about the volume ratio? Well, the volume ratio is the mole ratio. So the volume ratio has to be 2 is to 1. Okay, not 1 is to 2. Okay, so that's also wrong. So the answer is D. Example 5. Current flows from the positive terminal to the negative terminal. That's current. But electrons flow the other way. So electrons will flow from the negative terminal to the positive terminal, which means metal X is the more reactive metal, because the more reactive metal will give electrons to the less reactive metal. So option A is wrong, because copper should be less reactive. Option A is wrong. Option B, the mass of the copper electrode increases. To do that, we need the copper ions swimming to the copper electrode and being discharged to return back to copper atom form. But there are no copper ions in solution, only sulfuric acid. Hence, B is wrong. Now C, the mass of the electrode made of metal X decreases. That is correct. So when metal X gives electrons, it has to go into solution to become an ion. For example, if the ion is 2+ charge, then it will give 2 electrons. If it's 3+ charge, it will give 3 electrons, so on and so forth. That's just an example. Now, option D, electrode made of metal X is the positive electrode. That's wrong. It is the negative electrode. So the answer is C. Let us now look at question 6. First, let's place the metals at their correct relative positions. Now, question says that Y is more positive compared to Z. So let's put Y higher than Z, with the voltage between them being 1.6. It is also said that W is more positive than Y. So let's put W above Y. And the potential difference between W and Y is 1.1 volts. So rightfully, the total voltage between W and Z should be 1.1 plus 1.6, 2.7 volts. And indeed, it is 2.7 volts. So this is actually redundant. The last one is actually redundant information. So now, remember, in a voltaic cell, electrons flow from the negative terminal to the positive terminal. So this is the most positive, and this is the most negative. Now remember, electrons flow from the negative terminal to the positive terminal. In other words, Z is the most reactive metal, and W is the least reactive metal. Now the reducing power of metal is the reactivity of the metal. So we need to arrange them in decreasing order of reducing power or decreasing order of reactivity. So we have to arrange them according to Z most, followed by Y, and followed by W. So the answer is C. Let us look at question number 7. First, let's draw in the battery. The purpose of the battery is to draw electrons from the positive electrode or the anode and pump it out to the negative electrode, the cathode. So at the anode, ions must provide the electrons. Who can provide the electrons? The negative ions. Negative ions provide electrons. There are two negative ions, the sulfate ion and the hydroxide ion. The sulfate ion never ever gets discharged So it's the hydroxide ion that gets discharged. When the hydroxide ion gets discharged, there will be an imbalance between the H plus ions and the OH minus ions in the water. So there will be less hydroxide ions and more hydrogen ions, and so the solution will become more acidic, and hence the color of the solution will turn red on the left hand side. At the same time, because hydroxide ions are discharged, you will get oxygen gas bubbling on the anode side. Now at the cathode side, the incoming electrons can discharge positive ions. There are two positive ions, the sodium ion and the hydrogen ion. Sodium ion is higher in the reactivity series, it doesn't get discharged. So the hydrogen ion gets discharged, so you will get hydrogen gas appearing. At the same time, there will be an imbalance between the H plus and the OH minus ions. There will be less H plus ions and more hydroxide ions, so the solution will turn more and more alkaline. The question asks for what happens at the cathode. So the cathode is here on the right hand side. So we have to focus on this part here. First, color of solution. Because it's more alkaline, so it will turn blue. And the gas appearing is hydrogen gas. So the answer is A. Let's look at question number 8. The positive end of the battery is connected to the anode. The negative side of the battery is connected to the cathode. The purpose of the battery is to draw electrons from the anode and pump it to the cathode. So ions at the anode side, the N ions, must provide the electrons, because anions are rich in electrons, they can provide the electrons. So at the anode Y, we have to examine the anions present, and they are respectively chloride ions and the hydroxide ions. Because it is a concentrated sodium chloride solution, so the chloride ions will be discharged and the hydroxide ions will not be discharged. When the chloride ions are discharged, chlorine gas will appear. The chlorine gas will dissolve in water to give you two compounds. First, hydrochloric acid. Second, hypochlorite acid. This will turn litmus red because it's acidic, and this is a bleach, so it will whiten everything there. At the cathode X, electrons being pumped here will discharge positive ions. The two positive ions, the sodium ion and the hydrogen ion. The sodium ion doesn't get discharged, it's the hydrogen ion that gets discharged, so hydrogen gas will appear. And hydrogen gas is not very soluble in water, and it doesn't turn the litmus red or blue. Hence, the answer is B. The answer to question number 9 is B. Liquid metal alloys. Liquid metal alloys are just different metals mixed together, so it's still a piece of metal. A metal conducts electricity. It conducts electricity without being chemically affected whatsoever, so it will not be electrolyzed. Question number 10, the answer is D. The orchid itself is non-conductive. By coating a layer of metal or carbon, which is conductive, electrically conductive, then the orchid can now serve as the cathode and can participate in electrolysis. Question 11. We have a battery connected to both a copper anode and a copper cathode. Anode positive, cathode negative. The purpose of the battery is to draw up electrons from the anode and pump it to the cathode. So the anions attracted to the anode must provide the electrons. There are two anions drawn to the anode, the sulfate ion and the hydroxide ion. And rightfully the hydroxide ion should be preferentially discharged, but because we have a copper anode, copper itself can deliver the electron. So we have a third contestant. The copper itself can provide the electrons and go into solution. So it's not the sulfate ion that gets discharged, not the hydroxide ion that gets discharged. It's the copper atoms that get discharged to form copper ions. So the copper will discharge to become copper ions and release electrons to the other side, to the cathode side. At the cathode side, the incoming electrons can discharge positive ions. There are two positive ions, the H plus ion from the water and from sulfuric acid, and the copper ions from the copper sulfate. So the copper 2 plus ion lower in the reactivity series gets discharged. The hydrogen ion doesn't get discharged. The copper ion will receive 2 electrons and return back to copper metal form. So as the reaction goes by, the copper anode will shrink while the copper cathode will increase in size. So the substance formed at the cathode is copper metal. Answer is A. Let's look at question number 12. Now, ethanol is an organic compound. It doesn't have any ions. It cannot conduct electricity. Pure water is also covalent compound. It doesn't have ions. It cannot conduct electricity. You need a little bit of impurities, a little bit of ions in the water for the water to conduct electricity. So neither A or B can conduct electricity. Potassium hydroxide, aqueous potassium hydroxide, can conduct electricity. The one that provides the highest current is the one with the largest difference in reactivity series between the two metals. On the one hand, we both have copper metal. On the other side, we have zinc and iron. Now, zinc is higher in the reactivity series than iron. Iron is lower in the reactivity series. So which means the difference between zinc and copper is bigger, right? A bigger difference in reactivity series will lead to a bigger potential difference and hence a bigger current. So the answer is C. Let's look at question number 13. This is another voltaic cell. Zinc, being the more reactive metal, will give electrons to silver, which is the less reactive metal. In this case, the zinc, when it gives up electron, it will become a zinc ion, providing 2 electrons in the process. At the other end, the electron will be received by a positive ion. There is only one positive ion, which is the H+ ion in the sulfuric acid. So the H+ ion will receive the electrons and return back to hydrogen gas form. So what's going to happen at the zinc electrode is that the zinc metal will seemingly dissolve in the sulfuric acid. At the silver end, hydrogen gas will appear. So the answer is A. Question 14. Electrolysis of aqueous sodium sulfate. First, we draw the batteries. The positive end connected to the anode and the negative end connected to the cathode. The battery will pluck electrons from the anode and pump it out at the cathode. So at the anode side, the anions must provide the electrons. And in the case of the sodium sulfate, we have sulfate anion as well as hydroxide anion. Sulfate anion never ever gets discharged, so the hydroxide anion gets discharged. So oxygen gas will appear at the anode. At the same time, there will be an imbalance between the H+ and the OH- ions at the anode. So there will be more H+ ions and less hydroxide ions, so the solution will appear more acidic. So the pH will be less than 7. At the cathode side, the electrons appearing here will discharge positive ions. The 2 positive ions, the sodium ion and the hydrogen cation. The sodium cation higher in the reactivity series doesn't get discharged. The hydrogen ion lower in the reactivity series will be discharged again. So hydrogen gas will appear. Again, you'll find there's an imbalance of H+ and OH- ions. There will be less hydrogen ions. There will be more hydroxide ions. The solution will be alkaline and the pH will be more than 7. So at the cathode side, the pH is more than 7. At the anode side, the pH is less than 7. So we have to choose A. Question 15. They say that an electric current is flowing, so there must be a voltaic cell. Cell X comprises of 2 different metals. Cell Y comprises of carbon electrodes. So obviously, X is the voltaic cell providing the energy for the electrolysis. And cell Y will be the electrolytic cell. They also say that silver is being formed on the electrode S. To do that, electrons must arrive at electrode S so that the silver ion can receive the electron to return back to silver atom form, which means the electrons must come from electrode P, and hence P is the more reactive metal and Q is the less reactive metal. And also, since electrons arrive at the negative terminal, so this is the negative electrode and this is the positive electrode. This is the negative electrode that provides the electrons, and this is the positive electrode that receives the electrons. So we know what happens at electrode S already. Let's look at what happens at electrode R. At electrode R, electrons will be stripped from the anion. So there are two anions at electrode R, the nitric ion and the hydroxide ion. Nitric ion never ever gets discharged, so it's the hydroxide ion that gets discharged to become oxygen gas. In so doing, there will be an imbalance between H plus and OH minus ions. There will be less hydroxide ions and more hydrogen ions, so the solution will turn acidic. So the pH will go down to less than 7. At the voltaic cell, P will dissolve into solution to become ions and provide the electrons. At Q, well, Q will receive electrons, so those electrons must go to positive ions and discharge the positive ions. In the case of nitric acid, there is only one positive ion, the H plus ion. So the H plus ion receives the electrons and will get discharged as hydrogen gas. So you will get hydrogen gas appearing at electrode Q. Let us now examine the options. Option A, the pH of the electrolyte shall decrease. So the electrolyte refers to Y. In fact, it's written here, Y. They say the pH will decrease. pH will decrease. Now that is correct. Correct statement. B, the electrons flow in a clockwise fashion. Yes, the electrons flow in a clockwise fashion. So that is also correct. C, effervescence will be observed at electrode Q. Yes, hydrogen gas appears at electrode Q, so effervescence observed. Yes. And D, Q is more reactive than P. No, P gives electrons to Q, so P is more reactive. Q is less reactive. So the answer is D. Question 16. For simplicity's sake, let us assume that the ion of A is A plus, the ion of B is B plus, the ion of C is C plus, and the ion of D is D plus. When we have metal A reacting with the ion of B, what it means is that metal A is more reactive than metal B. So therefore metal A can displace metal B from B's solution. So since A can displace B, C, and D, A is the most reactive, followed by D, because D has two reactions. So D can displace B and C. A has three reactions, so D is number 2. So let's look for one reaction, that's B. B can displace C, and finally C has absolutely no reactions whatsoever. So C cannot displace any other metals. It is the least reactive. When it comes to discharge, it is the least reactive metal that gets discharged. So the metal that is most easily discharged is metal ion C. The battery will suck electrons from the positive anode and throw it to the negative cathode. So the anions, negative anions, will have to provide the electrons at the anode to the anode, and cations, positive cations, will receive the electrons at the negative cathode. Let's look at option A. Now, option A, we have molten sodium chloride versus aqueous sodium chloride. In terms of the cations, the molten sodium chloride only has Na+, but the aqueous sodium chloride has Na+ as well as H+, and H+ will be discharged, not Na+. So already this is different. So the answer is not A. Let's look at option B. For option B, let's examine the anions. For the dilute sodium chloride solution, we have two anions, the hydroxide and the chloride. For the concentrated sodium chloride solution, we also have the same ions, the hydroxide and the chloride. But in the case of the dilute solution, the hydroxide is the one that's discharged, the chloride is not discharged. In the concentrated solution, the chloride is discharged, the hydroxide is not discharged. Hence, there is already a difference. Now for option C, we have to compare hydrochloric acid versus sulfuric acid. Now obviously, the cations are the same, which is H+. But what about the anions? In the case of the dilute hydrochloric acid, we've got Cl- and OH-, of which Cl- will not be discharged, the hydroxide ion will be discharged. In the case of the dilute sulfuric acid, the sulfate cannot be discharged, it's the hydroxide ion that gets discharged. So the electrolysis are identical, so the answer has got to be C. Let's examine option D. Now for option D is similar to option B because one is dilute, the other one is concentrated. So for the concentrated, the chloride will be discharged. For the dilute, the hydroxide will be discharged. So the answer is C. We can attempt question 17 more quickly. The question asks for the product at Y. So we can focus on just Y, which is the positive electrode, which is the anode, which will attract the anions. So we can just focus on the anions. For option A, the molten sodium chloride's anion is just the chloride. The dilute sodium chloride anion comprises the chloride ion as well as the hydroxide ion. In the case of the molten sodium chloride, it has to be the chloride that gets discharged. In the case of the dilute hydrochloric acid, because it's dilute, the hydroxide ion gets discharged, so they are different. But the question wants the same, so they're different, so A is wrong. For B, we have to compare dilute chloride solution versus concentrated chloride solution. For the dilute chloride solution, it's the hydroxide ion that gets discharged. For the concentrated chloride solution, it's the chloride that gets discharged. So they're different. So B is wrong. Now for option C, in the dilute hydrochloric acid, the anions are hydroxide and chloride. In the sulfuric acid, the anions are again hydroxide and sulfate ion. Because it's dilute, Chloride is not discharged, hydroxide is discharged. Sulfate is never discharged, again hydroxide is discharged. So the anion discharge are the same, so the answer is C. Finally, we look at option D. We have to compare dilute hydrochloric acid versus concentrated hydrochloric acid. So option D is similar to option B. The ions are hydroxide and chloride. Hydroxide and chloride. And in the case of the dilute case, the hydroxide gets discharged, chloride is not discharged. For concentrated case, the hydroxide is not discharged, the chloride is discharged. So they are different. So the answer is C. Question 18 is focused on electrode X, which is the cathode. And so the negative cathode will attract the positive ions, the positive cations. So what are the cations in the solution? They are copper 2 plus ions and hydrogen ions. Since the hydrogen ions are higher in the reactivity series, they will not be discharged. Copper 2 plus, which is lower in the reactivity series, will be discharged. So the equation is this. Answer is A. For question 19, electrical energy in a simple voltaic cell is due to the transfer of electrons from a more reactive metal to a less reactive metal. The answer is D. Question 20. In aqueous potassium dichromate, there are 2 cations and 2 anions. The 2 cations are potassium and hydrogen. So these will be attracted to the negative electrode or the cathode. So the K plus and the H plus will arrive on the right hand side. The negative ions are the dichromate ion and the hydroxide ion. So these will be attracted to the positive electrode or the anode. Because the dichromate ion is orange in color, so the orange patch will migrate to the positive terminal. So orange patch migrate to the negative terminal, that is wrong. Blue patch move towards the positive pole, that is not correct because there's no litmus or whatsoever, so there's no blue patch. The orange patch moves towards the positive terminal, that is correct. And finally, purple patch. Purple patch is for the manganate. The manganate ion is purple patch. So, but there's no manganate here, so D is wrong. So the answer is C. Question 21. We have an voltaic cell whereby the more reactive magnesium is giving electrons to the less reactive copper. So what's going to happen at the copper side is that positive ions will receive the electrons and return back to metal form. There are 2 positive ions in the copper sulfate solution, the copper 2 plus ion and the hydrogen ion. So copper 2 plus is the metal that's lower in the reactivity series. It will be discharged. Hydrogen will not be discharged. So the copper 2 plus will receive 2 electrons to return back to copper metal status. Now because this is a reduction reaction, and the cathode is defined as the electrode where reduction takes place. Hence, this is the cathode. The copper metal will become bigger as more and more copper gets deposited at the copper cathode. On the other side, the magnesium will dissolve into solution to form magnesium ions, thus giving electrons. So this is an oxidation reaction, thus this is the anode. Let's see which options are correct. Mass of copper remains the same. That is wrong. It will increase because of this deposit. Mass of magnesium decreases. Yes. Electrons flow in this direction. That is correct. Copper is the cathode. That is also correct. Chemical energy transformed to electrical energy. That is also correct. So the answer is 2, 3, 4, and 5. That's it. Question 22. Electrolysis of copper sulfate using copper electrodes. Let's draw the batteries. So the positive end is connected to the positive anode. The negative end is connected to the negative cathode. At the anode side, electrons have to be provided so that they can be pumped to the cathode. Now there are 3 ways to provide the electrons. First, it can come from the hydroxide ions. Second, it can come from the sulfate ions. And third, the copper itself can provide the electrons. And in fact, this is the way it goes. So the copper will dissolve into solution to provide those 2 electrons. So the answer is C. Let's learn more. What happens on the other side? On the other side, the positive ions, the cations, will receive the electrons and return and be discharged. And there are 2 cations, the copper 2+ cation and the H+ cation. So the H+ cation is not discharged, the copper 2+ cation is discharged. And so the copper 2+ will receive the 2 electrons and return back to copper metal form. Question 23. Let's examine the options one at a time. Option A. The anode will attract the anions. There are 2 anions, the sulfate as well as the hydroxide. The sulfate is never discharged, the hydroxide will discharge, and you will get oxygen gas. The cathode will attract the cations, and so you will get, there are 2 cations, the K+ and the H+. K+ is higher in the reactivity series, won't be discharged. H+ lower in the reactivity series will be discharged, and so you get hydrogen gas at the cathode. So A is correct. The answer is A. Let's learn more. Let's look at option B. Now option B, we have aqueous sodium chloride. Again, at the anode side, we have the anions, which are the chloride ions, anion, and the hydroxide anion. Now, they didn't say it's dilute or concentrated. We'll assume it is dilute. So the chloride ions are not discharged, the hydroxide ions are discharged, and you will get oxygen gas. So that is possibly wrong. Possibly wrong. Now at the cathode side, we have 2 cations, the sodium cation and the hydrogen cation. Sodium is never discharged, so it's the hydrogen ion that gets discharged, giving you hydrogen gas. So sodium is definitely wrong. So B is definitely wrong. Let's look at option C. Now option C, we are talking about liquid sodium hydride, which means it's a molten sodium hydride. So the ions are clear. There's only one anion and one cation. At the anode, the only anion is the H minus anion. The cathode, you have the Na plus anion. Sorry, Na plus cation. So you'll get sodium at the cathode, you'll get hydrogen gas at the anode. So these are reversed, so that's why C is wrong. Let's look at D. D is again a molten compound, molten ionic compound. So at the anode side, we have the anion, which is bromide. At the cathode side, we have lead, Pb2+. So obviously we're going to get lead from the cathode, and we are going to get bromine at the anode. So again, these are reversed, so this is wrong as well. So answer is A. Question 24. These are voltaic cells. The more reactive metal gives electrons to the less reactive metal. So in the first cell, X is more reactive than Y. In the second cell, Y is more reactive than Z. So copper is more reactive than silver, correct. Silver is not more reactive than zinc, incorrect. A is wrong. Silver more reactive than copper, wrong. Copper more reactive than zinc, also wrong. Copper more reactive than zinc, not correct. Zinc more reactive than silver, correct, wrong. Zinc more reactive than copper, yes. Copper more reactive than silver, yes. Answer is D. Question 25. Gold electroplating of the shield. We have a shield that we want to coat with a layer of gold, which means we want the gold ions to go to the shield. So the shield has to be negatively charged by connecting it to the negative end of the battery. So the positive end will be connected to a piece of gold. So the negative electrode is the shield itself. The positive electrode is the gold, and the electrolyte has got to be a gold compound. So the answer is B.